In the first lesson, what we are going to discuss is about the just our first lesson is force and motion, right? Now, before begin that, right, we have to discuss one or two terms first, right? So that term is quantity. Now, a quantity means something that we can measure, right? For example, length, a time, temperature, right? Speed, anything that we can measure, we call them as a quantity, right? Now these quantities generally we can divide into two types: scalar quantities and vector quantities. Scalar quantities means, right, so they only have a size, right? So another name for the size is, we normally say it has only a magnitude only, right? And the vector quantities means they have both size and direction, right? Now when, for example, right, when you say a force, right, now the force, let's say we have an object here, depends on the direction we apply the force, the direct motion, the direction of the motion will be changing. So therefore, when you're applying a force, the direction plays an important role. So therefore, direction and the size of the force, they both affect this one, right? So therefore, when it comes to a force, so we can identify a force as a vector quantity. But when it comes to scalar quantities, now for example, temperature, right? Now the temperature, when you say 25 Celsius, right? So there is only a number, the 25, right? So there is no direction involved. So those kind of quantities we call them as scalar quantities and vector quantities, right? Now whatever the quantities we meet through in our lessons, right? So we need to identify them as scalar quantities and vector quantities as we go along in the lesson, right? Therefore, first we can make a small note about this one. So you can write this one. A quantity means something that we can measure, right? So if you want, you can mention example, a length, time, anything, any example. So then these quantities we can divide into two: scalar and vector quantities. So scalar quantities, they only have a magnitude. Magnitude means a size. For example, time, distance. Now the vector quantities examples, that means they have both magnitude and direction. So examples are force and velocity, right? Now in our first lesson, the first part is about the motion of the objects, right? Now when it comes to the motion, remember, so then there are several terms we have to discuss, right? Now one term is called distance, right? Other term is called displacement. Now if you consider 2 points A and B like this, right? Let's say there are two paths to go from A to B, right? So one is this kind of curvy path, so other one is this straight line like path, right? Two paths are there. Now the distance means, right, so length between two paths in any direction. So it's a length in any direction, right? So that means if you go along this curved path, right, so at a certain point, right, now let's say point, this point, you will be moving in a direction like this. At this point you will be moving in a direction like this. In a point like this, you will be moving in a direction this way, right? So at different points you will be moving in different direction. So then the length between this path, along this path, is the distance between the A and B along this path, right? But the displacement means, right, so the length in a specific direction along a straight path, right, there to there, right? Even if you want, you can go from B to A, then there's a specific direction, depends on where you are going, A to B or B to A. There are two different displacements are there. The difference means only the direction wise it is different, but the size, the length wise, it is same. So then displacement simply means a length but in a specific directions, right? So therefore when it comes to distance, right, so then distance and displacement both are lengths. The only difference is the distance we don't consider about any direction involvement, but in a displacement, direction involvement is important, right? So therefore, since there is no direction in the distance, we can identify the distance as a scalar quantity, and the displacement we can identify them as a vector quantity, right? And we, both of them we can calculate now the both are lengths, right? So the lengths are measured using the units meters. So then the measuring unit of the length is meters. So then distance and displacement both, they both measured in meters. So the symbol for the meters length is m, right? So this is what I have mentioned in the note here. So then distance and displacement, you can write down this one, right? So distance means length of a path, right? For this one you can add in any direction, right? And it's a scalar quantity and the SI unit is meters, m. Then displacement means length of a straight path into a straight direction only, and it is the shortest distance between 2 points, right? So you can see if you take the distance, shortest distance is the distance along this path in the straight path, that is also equal to the displacement. And so it's a vector quantity, and the basic unit is SI unit is meters, right? Now when it comes to the these motions, right? So there are some more terms we have to discuss. One is speed, right? So then simply speed means, now let's say the distance along a path is 10 meters, right? A person take 5 seconds to go from starting point to the end point, right? So speed simply means it's the distance divided by time, right? Speed means distance divided by time. So we can give it a, now for this case we can say it is distance is 10 divided by 5 is answer is 2. So then it means the speed is 2 means actually if you want to travel this 10 meters distance within 5 seconds, right? So then he has to travel 2 meters in every second, right? So therefore speed we can identify it as distance traveled per 1 second. 1 second we can say it as unit time also, right? So simply distance means sorry, speed means distance traveled per second or distance traveled per unit time. We calculate using the equation distance divided by time. Now the thing is, when you are moving in a path like this, generally the speed can be changing, right? When we know when we are moving from one point to another, right, we will not be moving at the same speed. Sometimes we speed up, sometimes we slow down, right? So as a result what will happen, different points, the speeds will be changing, right? So because of this this equation we normally write it like average speed. Average speed is distance over time. So that means if you are moving through the entire path with a constant speed, that speed is equal to 2 meters per second, right? uh, and since this is distance divided by time, okay, so then distance is measured with meters, time is measured with seconds. Then meters divided by second, the units of this one we can write as meters per second. So therefore speed is measured using meters per second, right? So if you generally we are in your papers and everywhere you see the meters per second unit written like this, but if you want you can write this way also, write in internet or books. Sometimes we will see this method also, but we will be using this one because that's what given in the textbook, right? So you can write this part as a noun, right? The speed, distance moved per unit time. And remember, so since distance and the time both are scalar quantities, speed is also known as a scalar quantity, and the SI unit is meters per second, right? So you can write this as a formula: average speed equals distance traveled divided by the time taken. And the symbols we are using for this is v equals d by t. So v is the average speed, t is the distance traveled, and t is the time taken. Okay, right. So the next part is velocity, right? Now similar to distance, right? So velocity is taken as displacement divided by time, right? So how much displacement is there per unit time, right? So if someone is going along a straight path, right, so then how much displacement occurs, how much displacement he moves per second, within 1 second is what we call as the velocity, right? So since this is a displacement, so that means he's going in a specific direction. So then the velocity also considered as a vector quantity, because it also has the same direction when you're moving from, let's say, A to B, right? So the direction is that particular direction, right? So therefore this is also having a direction, that means it's a vector quantity. So displacement also measured with meters, the time is again seconds. So the units of the velocity is also taken as meters per second. To add this part into a note, right? So we can mention it like this. So rate of change of displacement, the velocity, we can say rate of change of displacement. Another way of saying this is displacement per 1 second, right? Rate means when you divide something by the time, we say it is the rate, right? So if you divide the temperature change by time, we can say it is the rate of temperature change, right? So rate of mass gain or anything like that. So if the mass is increasing, right, so if you divide by time, so that means the rate of mass gaining, right, like that. So whatever the component divide by time, we can say it is the rate of that particular thing, right? So since we are dividing the displacement by the time, we can say velocity is the rate of change of displacement, right, or rate of displacement, right? And it is a vector quantity, and the SI unit is meters per second, right? And remember, so for velocity, the displacement, the sign we are using is S, right? For the distance, we use the sign D. Is displacement, we are using the sign S, and speed and velocity both we are using the symbol V. And sometimes in your papers, right? So this velocity is also, sometimes it can be given as average velocity. So you say it's the average velocity or the normal velocity, generally it means the same thing, right? Let's say how we can apply this in a question. Now, as a example, right? So, a question: a car travels 200 kilometers in 5 hours. Calculate the speed of the car in. The first part is kilometers per hour. Second part is meters per second. Right? Now, kilometers per hour we use generally in like most of the times, right? So, especially when you're going the speed of a vehicle or something, we can give the speed in kilometers per hours, right? And but the main SI unit is, remember, it is meters per second, right? If you want, you can try the question by pausing the video for a while, right? And to explain this answer, right? So now first part. So if you want the speed, speed is distance divided by time. Then distance is, we are given 200 kilometers. Time taken is 5 hours, right? So then if you take the time in hours and the distance in kilometers, when you divide this, answer is coming as kilometers per hour. So then 200 divided by 5 is 40 kilometers per hour. And to give this value in meters per second, right? So if you want, you can change the values here. 200 kilometers per hour, 200 kilometers into meters by multiplying by 1000, or 5 hours into second by multiplying by 60 and again by 60. Or else we can, since we know the speed in kilometers, we can use that one too, right? So 40 kilometers per hours, that means 40 kilometers in 1 hour, right? To convert kilometers into meters, kilometers means you have to multiply this by 1000 into meters. Hours means 1 into 1 hour means 60 minutes. Each minute contains 60 seconds. So then we get the answer from this equation. So the answer is coming as, I think, 11.1 meters per second. 11.111, right? Even if you write as 11, that's also fine, right? We try another question. Right, here's a question, another one. A car travels at a speed of 20 meters per second on a road. Calculate the time taken to travel 465 meters. Calculate the distance traveled in 8 minutes. Speed limit of the road is 80 kilometers per hour. Has the car exceeded the speed limit of this road? Right. Right. So if you want, you can take a minute and try this question. Right. Stopping the video for a moment. Right. So we know the equation speed equals distance over time. Right. So the first part we are trying to get the answer. So then we are given the speed and we are given the distance. We are trying to find out the time taken. Right. So then if you multiply both sides by the time, we get v into t equals the distance. Right. Because this time is cancels out. So then the time is equal to distance divided by v. Both sides divided by v. Here both sides multiplying by t. Right. So then distance is 465, the speed is 20, so we get the time as 23.25 seconds. Right now, because everything meters per second, distance is in meters, so then therefore the time is has to be given in seconds. Second one, again speed equals distance over time. In this case, you are given the time, you have to find the distance in distance, right? So then again multiplying this equation with time, right? We get distance equals speed into time, right? So just like this step, right, same equation is there, right? Now we are trying to find the distance. So the speed is given in meters per second, right? Now this is meters per second. So therefore we can't, now the time in the question it is given as meters. We can't have the time in minutes because we need to convert this into seconds, right? Otherwise these units do not match. So then 8 minutes to convert into seconds, we have to multiply it by 60. We get the answer I think as 9600 meters. 20 meters per second means 9600 meters. Next one, calculate the speed limit of the road is 80 kilometers per hour. Has the car exceeded the speed limit? Right now we are given the speed as 20 meters per second. The limit is 80 kilometers per hour. Right now we have to convert this 80 kilometers per hour into meters per second to make sure it is exceeding or no, or meters per second we can convert into kilometers per hour, right? So we'll try both methods, right? In exam you can try only, you need only try one method, right? So we try to convert 80 kilometers per hour just like the previous calculation. That means 80 kilometers in 1 hour. So 80 multiplied by 1000 gives us the meter value. 1 hour multiplied by 16 to 60 is the seconds, right? So I think we'll be getting as 22.2 meters per second, right? So then you can say, yeah, this value is higher than 20 meters per second, so therefore the speed limit has not exceeded, right? So the maximum value is 22.2, so then the car is traveling at 20 means it is not exceeding the limit, right? So you have to give the comment. Then second method is converting 20 meters per second. That means 20 meters in 1 second. Then to convert this 20 meters into kilometers, you have to divide this by 1000. Right? So 1 second means, right? So 16 to 60. Right? So we know 1 hour means 60 minutes into 60 seconds. So that means 3600 seconds. So then 1 second means 1 divided by 3600 to convert this into hours. Let's see what we get. So we get the answer as 72 kilometers per hour, right? So then we know the maximum speed is 80. So then this is less than 80 kilometers per hour, means speed limit has not exceeded.